Welcome, my dear students. Now, again we are continuing the complex number topic. And not only this, for 3 more classes also we have to deal with the complex numbers. So now we continuation of the first one. So we are continuing the problem number 12 or 13. 13. So the number of complex numbers Z number of complex numbers Z such that modulus of Z minus 1 is equal to modulus of Z minus Z plus 1 is equal to modulus of Z minus I is 1, 0, 2, 1, 3, 2 and 4 infinite. You know that all of you know the concept of Argand's plane. Argand's plane is nothing but a plane in which every complex number is represented by means of a point x comma y. And you know that when if Z1 and Z2 are complex numbers, then modulus of Z1 minus Z2 is nothing but the distance between the points. The distance between the points represented by Z1 and Z2. So therefore mod Z minus 1 is equal to mod Z plus 1 is equal to mod Z minus I implies the point Z is equidistant from the points 1 comma 0 and minus 1 comma 0 and 0 comma 1, and which represents the vertices of a triangle, which represent the vertices of a triangle. Vertices of a triangle. And you know that in any triangle, the only point which is equidistant from all the 3 vertices is nothing but the circumcenter. Is nothing but the circumcenter of the triangle. So there is only one point. So in any triangle, and for a triangle, circumcenter is the only point equidistant from the vertices. So therefore answer is 2. We next take up problem number 14. If modulus of Z minus 4 by Z is equal to 2, then the maximum value maximum value of mod z is number 1 2 root 5 plus 1 3 2 plus root 2 and 4 root 3 plus 1. Right? And you know, of course, in your classes, your teacher, lecturer taught the properties of modulus. So, by the properties of modulus, we know that modulus of mod z1 minus mod z2 is always less than or equal to mod z1 minus z2. This is a fundamental property of modulus this is being proved in your regular class itself. So this from this implies modulus of, you can write that is modulus of mod z minus 4 by z, 4 by mod z is less than or equal to modulus of z minus 4 by z, because here you can see z1 is nothing but mod z, z2 is nothing but 4 by mod z. Understand? So it is less than or equal to modulus of z minus 4 by z, and you are given that is equal to 2 by hypothesis. So this implies that minus 2 less than or equal to mod z minus 4 by mod z, which is less than or equal to plus 2. Now the second inequality, mod z is equal to 2 you are given, is not? So this is the second inequality gives that mod z minus 4 by mod z, this is less than or equal to 2, implies mod z square minus 2 mod z minus 4 is less than or equal to 0. It is less than or equal to 0 itself. So this shows that I will give you z mod z minus 1 whole square is less than or equal to 5. So mod z minus 1, so therefore mod z minus 1 less than or equal to root 5. So which is mod z is less than or equal to root 5 plus 1. So the maximum value of mod z is root 5 plus 1. So here please see, you can see that is this inequality also is there minus 2, but from this what you get is z mod z square minus 4z plus 2 less than or equal to 0, and you will get mod z less than or equal to 1 minus root 5, which is absurd. 1 minus root 5 is absurd itself. So mod z square minus 2 mod z minus 4 is less than or equal to 0. That means mod z minus 1 whole square less than or equal to 5. So taking square root, mod z minus 1 is less than or equal to root 5. So mod z is less than or equal to root 5 plus 1. So that is the maximum value. So the answer is number 2. The minimum value of mod z is root 5 minus 1. We will go to problem number 15. If z is not equal to 1 and mod z is equal to 1, then all the values of z by 1 minus z square, z by 1 minus z square lie on number 1. Number one, a line not passing through origin, not passing through through 0, 0 and 2 mod z is equal to root 2 3 on real axis that is x axis and 4 on imaginary axis that is y axis. And you are given that mod z is not equal to 1 and z is not equal to 1. Understand? So therefore, now the solution is let alpha is equal to z by 1 minus z square. Z by 1 minus z square. So that take alpha bar is equal to z bar by 1 minus z bar whole square. That is conjugate, the complex conjugate. So now this you can write as 1 by z by 1 minus 1 by z square, since mod z is equal to 1 implies z into z bar is equal to 1. So z bar is 1 by z and z is 1 by z bar. So this shows that what you get is z square z by z square minus 1. So which is minus alpha, which is equal to minus alpha. So alpha is equal to minus alpha. So alpha bar is equal to minus alpha. So therefore alpha must be pure real. Alpha bar is equal to minus alpha means alpha must be pure real. So alpha bar is equal to minus alpha implies alpha is pure imaginary. So therefore alpha lies on y axis. So that means the answer is number 4. Imaginary axis or y axis both are same. So now we will go to the next problem. Stressing you that for mod z value instead of square root of x square plus y square, mod z is equal to, when z is equal to x plus iy, it is always useful in many problems that if you use z bar is equal to mod z whole square. Now we take up problem number 16 is if x and y are positive integers, x and y are integers and z is equal to x plus iy, then the area of the rectangle, area of the rectangle whose vertices are the roots of, whose vertices are the roots of the equation, z bar z cubed plus z bar cubed is equal to 350, z bar z cubed plus z bar whole cubed So that means for one z bar is there, another z bar is bar without bar is equal to 350 is 1 48 2 32 3 40 and 4 80. Of course, here the units are square units. 48 square units, 32 square units, 40 square units and 80 square units. So the solution is, please carefully see, this is a very good problem. Now the given equation can be written as z bar into z square plus z bar square is equal to 350. Z bar into z square plus z bar square is equal to 350. Now z is equal to x plus iy implies that is x square plus y square mod z whole square into that is x square plus y square, x square plus y square into that is z square plus z bar square is 2 into x square minus y square is equal to 350. Because you know that z is x plus iy, z bar is x minus iy. Z bar is x minus iy. So this equation is mod z whole square means x square plus y square into z square plus z bar square is 2 into x square minus y square is equal to 350. So that implies x square plus y square into x square minus y square is equal to 175. Dividing by 2, it is 175, and for this the factorization is 5 into 5 into 7. 5 into 5 into 7, 25 into 7. 25 into 7 is 175 or not? 175. So this. So therefore here, now here you have to apply the basic arithmetic. X square plus y square into x square minus y square is 5 into 5 into 7. So out of this, one must be 25 and the other is 7. Or one must be 35 and the other is 5. Two cases will arrive. So we will discuss both the cases. So that implies x square plus y square is equal to 35 and x square minus y square is equal to how much you will get? 25 and 7. 25 and 7 or x square plus y square is equal to 35, 7 into 5, 35 and x square minus y square is equal to 5. Now you can see that is this one. So in this case, we will find out x and y, and in this also we can find out x and y, but we have to see, bear it in mind that x and y are integers. So we have to take the answers where x and y are integers only. Right. Now case 1. X square plus y square is equal to 25 and x square minus y square is equal to 7. So when you adding 2x square is equal to 32 and 2y square is equal to 25 minus 7, which is 18. So that implies x square is equal to 16 and y square is equal to 9. So that implies x is equal to plus or minus 4 and y is equal to plus or minus 3. So therefore here in this case the vertices are are 4 comma 3 and minus 4 comma 3, minus 4 minus 3 and 4 minus 3. Those are the 4 bits of the triangle and the rectangle. So now you know that the area of the rectangle is length multiplied by breadth. So area of the rectangle is equal to length into breadth. So which is square root of these two sides. So the square root of 64, I think I will tell you. 64 into square root of 36. Now I will draw the diagram. 4 comma 3, minus 4 comma 3 and minus 4 minus 3 and 4 minus 3. Those are the bit size. Now this length is 8 because this is what is the length of this one? 4 minus 4 comma 3 minus 4 comma 3 and so 4 minus 4, this is 3 square plus 3 square 18 is not. What are the brackets? A, B, this is in first quadrant, this is in the second quadrant, this is in third quadrant, this is in the fourth quadrant. So the area is simply root 64 into 36, which is equal to 48. 8 into 6, 8 into 6, which is 48. Because I have inverted a rectangle, but this is nothing but 8 and this is nothing but 6. Okay, but what about the second case? If you take up the second case and you don't get the values of x and y as integers, you will get non-integer integral values. So that's why only you have to take the first case. Case 2, if you want, you can see case 2. 2x square is equal to 40 and 2y square is equal to 30. So from this you will get x square is equal to 20 and y square is equal to 15. So x and y are not integers. Here the x and y are not integers. So this implies that x and y are not integers. So now we will go to problem number 17. If mod z is equal to 1 and omega is equal to z minus 1 by z plus 1, where of course z is not equal to minus 1. We take up problem number 17. So if mod z is equal to 1 and omega is equal to z minus 1 by z plus 1, for z is not equal to minus 1, then the real part of omega is equal to 1, 0, 2, 1 by z plus 1 whole square and 3 mod z plus 1 whole cubed and 4 root 2 by mod z plus 1 whole square. So real part of omega we have to calculate. Okay. So and all of you know that if z is a complex number, z plus z bar by 2 is real part of z and z plus z bar by 2i is imaginary part. So now that we know that for any complex number z, Z. Z plus Z bar by 2 is equal to real part of Z, and Z bar minus Z bar by 2i by 2i is equal to imaginary part of Z. So from that we will take up now omega bar is equal to Z bar minus 1 by Z bar plus 1. Now we are given that mod Z is equal to 1. Mod Z is equal to 1 means Z bar is equal to 1. So this we can write as 1 by Z minus 1 by Z plus 1, since Z bar is equal to 1. So this is 1 minus Z by 1 plus Z, which is minus omega, which is equal to minus omega. That means, so therefore omega is pure imaginary. Pure imaginary. That means real part is 0. Pure imaginary, you know that x plus iy is pure imaginary when x is equal to 0, and pure real when y is equal to 0 itself. So the answer is number 1. We will take up problem number 18. If Z1, Z2, Z3 are complex numbers, are complex such that, of course, when I write complex means complex numbers, such that mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3, each is equal to 1, then modulus of Z1 plus Z2 plus Z3 is 1, is 1, 2, less than 1, 3, greater than 1, greater than 3, and 4 less than 3. Okay, right. And we know that Z mod Z whole square means Z into Z bar. So you know the solution, mod Z whole square means Z into Z bar. So that is equal to Z into Z bar. So therefore modulus of 1 is equal to modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3. This is given as Z1 bar plus Z2 bar plus Z3 bar. Because mod Z1 is equal to 1, mod Z2 Z2 is equal to 1, mod Z3 is equal to 1, and this is also equal to 1 you are given by hypothesis. But you know that this is mod Z1 plus Z2 plus Z3 whole bar, and you know that Z1 plus Z2 whole bar conjugate of sum is equal to sum of the conjugates in complex numbers. So Z1 plus Z2 plus Z3 whole bar, this is same as Z1 plus Z2 plus Z3 whole bar. So this is mod Z1 plus mod Z2 plus mod Z3. So what is the value? Mod Z1 plus Z2 plus Z3 is equal to 1. So the answer is 1. So here see, previously I told you in the last class, now this I am stressing. Instead of mod Z is equal to square root of x square plus y square, you always try to use Z into Z bar is equal to mod Z bar whole square, mod Z whole square. That is very essential in many problems. So now we take up problem number 19. If mod Z minus 4 is less than mod Z minus 2, then Z lies on the region one REZ is equal to greater than 0, 2 REZ is less than 0, 3 REZ is greater than 2, 4 REZ greater than 3. Okay, right. Now actually if you see that is mod Z minus 4 means the distance between Z x comma y and 4 comma 0. Mod Z minus 2 means the distance between xy and the point 2 comma 0. What you are given is the distance between x comma y and 4 is less than 4 comma 0 is less than the distance between x comma y and 2 comma 0. So now the solution, if you see, this is just algebraic explanation. So Z is equal to x plus iy implies that is x minus 4 whole square plus y square is less than x minus 2 whole square plus y square. So that implies x square will cancel, y square will cancel, minus 8x plus 16 is less than minus 4x plus 4. So that implies if you take a 12 is less than 4x. Sorry, 4x. That is 3 is less than x, and x is nothing but real part of z. X is nothing but real part of z. So real part of z is greater than 3. Real part of z is greater than 3 itself. So z lies on the region for which real part of z is greater than 3. So therefore answer is 4. We will take up problem number 20. If 1 omega square are cube roots of unity, and n is any positive integer, then the value of delta is equal to determinant 1 omega power n omega power 2n and omega power n omega power 2n 1. Next omega power 2n 1 omega power n is number 1 2 omega 3 omega square and 4 0. Right? Now here you not do anything, just because the terms are very simple, you expand the determinant, and we know that omega cubed is equal to 1 and 1 plus omega square is equal to 0. So therefore, expanding delta is equal to 1 into omega power 3n minus 1 minus omega power n into omega power 2n minus omega power 2n plus omega power 2n into omega power n minus omega power 4n. And you know that this is 1 into 1 minus 1 minus omega power n into 0 plus omega power 2n into this is omega power n minus omega power n, because omega power 4n is equal to omega power 3n into omega power n. So the entire one is 0. The value of the determinant is equal to 0. So therefore the answer is 4. Now we will take up problem number 21. If x is a positive integer, such that 1 plus I by 1 minus I whole power x is equal to 1, then for some positive integer n, for some positive integer n, 1 x is equal to 2n, 2 x is equal to 4n plus 1, 3 x is equal to 2n plus 1, and 4 x is equal to 4n. And now the solution is very simple. You know that I to the power of I square is equal to minus 1, I cubed is equal to minus I to the power of 4 is equal to plus 1. Again the cycle starts. Omega power 5 is equal to I square, I cubed is equal to minus I to the power of 4 is equal to 1, and I to the power of 5 is equal to I, etc. like this. So therefore 1 plus I by 1 minus I whole power x is equal to 1 means 1 plus I into 1 minus I, 1 plus I by 1 plus 1 whole power x is equal to 1. So this 1 plus I whole square is 2i by 2, 2i by 2 whole power x is equal to 1. So that means I power x is equal to 1. So therefore x must be a multiple of 4. X must be 4n. Because I power 4 is equal to 1, I power 5 is I power 6 is minus I cubed, I power 8 is again 1. So I power 4n is always 1, I power 4n is always 1. So therefore I power x is equal to 1 implies x is equal to is of the form 4n. So answer is 4. So we take up now problem number 22. If mod z square minus 1 is equal to mod z whole square plus 1, then z lies on number 1 a circle, 2 the imaginary axis, 3 real axis and 4 an ellipse. If mod z square minus 1 is equal to mod z whole square plus 1, then z lies on either a circle or imaginary axis or real axis or an ellipse. Okay? Right. So, this is just a verification. Suppose z is equal to x plus iy, then by hypothesis x square z square minus y square minus 1 plus I into 2y is equal to mod z means x square, see mod z whole square, sorry, that is 1, okay, x square plus y square plus 1. See, this z is equal to x plus y, then by hypothesis modulus of z square minus 1 means x square minus y square minus plus 2xy minus 1 is equal to x square plus y square plus 1. Right. On simplification, we get that 4x square equal to 0 or x is equal to 0. That means z lies on, therefore z lies on the imaginary axis. Z lies on the imaginary axis. Right. Imaginary axis means what is the answer? Number 2. Okay, my dear students, of course, in this session we did some problems on complex numbers, but still we continue for 2 or 3 more classes. The thing is, see, at your level, especially inter and MSET and mains level, you can solve the problems by taking z is equal to x plus iy. But z into the mod z is mod z, you always take it as mod z whole square is z into z bar.